Hello everyone and welcome back to the math. So in this video, we are going to learn how to sketch a quadratic function. If you haven't watched the previous videos regarding quadratics, I'll leave a link of the playlist on the top right. To sketch a quadratic function, there are four main steps. The first one, we need to know whether the shape of the parabola is going to look like a happy face or a sad face. The next step, we need to find the x-intercept and the y-intercept. And the third step, we need to find the turning point or the stationary point or the vertex. And the last step, we need to find the equation for the line of symmetry. And we're also going to look at how we can try to derive a quadratic function from its graph. Let's try to review a bit on what we know about quadratic functions so far. So if the quadratic function is in the form of ax squared plus bx plus c, we know that if a is positive, it's going to shape like a happy face, and if a is negative, it's going to shape like a sad face. And it also applies if we try to complete the square such that the form of the expression changes. We know that if d is positive, we will have a happy face. If d is negative, we will have a sad face. Now, the next step is to find the x-intercept and the y-intercept. So the x-intercept is actually the coordinates in the form of x, 0. Technically, you need to find the x value when the y is 0. And then for the y-intercept, it's going to be in the coordinates of the form 0, y. And this basically means you need to find the y value when the x is 0. Let's try to take a look at the examples. So in this case, let's try if we want to find the x-intercept. So if we want to find the x-intercept, that means the y should be equal to 0. So we will get ourselves a nice quadratic equation. We can try to factorize this and we get that x is equal to -1 or 3. So the x-intercept is going to be -1, 0 and 3, 0. After this, if we want to find the y-intercept, we can try to input the x value equal to 0. So we get that the y should be equal to -3. Therefore, the y-intercept is going to be 0, -3. Now, the next step is to determine the turning point and equation for the line of symmetry. So for the turning point, I think we're going to use this formula. And again, if you have trouble on memorizing the formula, you can always try to complete the square and then use the simpler formula. But for this one, I will try to use this formula, okay? So as we know, it's going to be minus b over 2a, comma, b squared minus 4ac over minus 4a. That's the coordinate of the turning point. So we can just try to input the ABC values over here. And we know that the x is going to be equal to 1 and the y is going to be -4. So the turning point is going to be 1, -4. And we know that the line of symmetry is going to be the x, which is x equals to 1. And again, remember, if we want to know whether the turning point is a minimum or a maximum point, we can always see the a value. In this case, the a is positive, so the turning point is going to be a minimum point. Now we go into the main part. But before that, I will try to get myself a Cartesian coordinate graph. The length of one square is actually 1 unit of length. Okay, so the length of one square is actually 1 unit of length. And then we can try to gather up all the informations that we have so far. So the first one, we know that A is going to be positive, so the graph will look like a happy face so that we can get a general overview on what the graph will look like. After that, we have the x-intercept, which is -1, 0 and 3, 0. We can try to plot these values in the graph so that it will look like this. After this, we know that the y-intercept is 0, -3. So it's going to be over here. And then the turning point over here. And then we can try to draw the line of symmetry, which is x equals to 1. Now, we have to remember that the graph is always going to be symmetrical to the line of symmetry. That is what the line of symmetry is used for. And after this, we can try to sketch the graph and it will look like this. In the test, usually you try to sketch it manually. You don't really need to be concerned on being perfect. You can just try to sketch it with pencil or pen such that you can make a curvy line. If you can make a curvy line, then I think you'll be fine. If you're unsure about your work, you can always try to check it with online geometry resources like Desmos or GeoGebra. Now, let's try to take a look at another example. So again, the first step, we need to find the x-intercept. So to find the x-intercept, it's basically finding the roots of the equation, and we got that the root is 1 and 3. So the x-intercept is 1, 0 and 3, 0. After this, we find the y-intercept, which is basically the y value when x is 0. So we can try to input the x equals to 0, and we know that the y is -3. So the y-intercept is 0, -3. After this, we can try to find the turning point and the line of symmetry. So we can try to use the formulas we know before, and we know the turning point is 2, 1, and the line of symmetry is x equals to 2. Now in this case, we have to remember that the a is negative, so the turning point is a maximum point. Now let's try to sketch the graph. Again, I will try to take out the Cartesian coordinate graph, and let's try to gather up all the informations that we know. So first, a is less than 0, so the graph will have a sad face. And then we know the x-intercept. We can try to plot the x-intercept, and then the y-intercept over here, and then the turning point over here. After this, we can try to plot the line of symmetry, which is x equals to 2. And again, the graph will be symmetrical to the line of symmetry, and then we can try to sketch it. You can try to sketch it manually with pen and paper, and you don't really need to be concerned about being perfect. You can just try to draw a curvy line and you will be fine. And again, you can try to check whether your work is okay or not with online geometry resources like Desmos or GeoGebra. Okay, so now let's try to get into the other example. So in this case, we know that the form of the quadratic function is different, but we're going to do it with a similar method. So first, we can try to find the DHK, and then we can try to find the x-intercept. Again, the y is going to be equal to 0, so we can try to find the x, and the x is going to be 1 or -3. So x-intercept 1, 0 or -3, 0. After this, we can try to find the y-intercept. So inputting x equals to 0 will gives us y equals to 3, and then we know that the y-intercept is 0, 3. After this, we can try to find the turning point. So for this one, the formula is going to be much more simpler than before, because we know that x is equal to -h and y is equal to k. So the turning point, -1, 4, and the line of symmetry, x equals to -1. And also remember that d is negative, so this will be a maximum point. Okay, so let's try to draw the graph. So again, we know that d is negative, the graph will be a sad face. We plot the x-intercept, we plot the y-intercept, we plot the turning point, and then we plot the line of symmetry. The graph will be symmetrical, and we can try to draw it like this. Again, we can try to check it with Desmos or GeoGebra. Now, in this example, it's going to be a bit different than the one before, because as you can see later, we have no x-intercept in this case. So when y is equal to 0, you actually get an imaginary root. And we know that x-intercept needs to be a real value. So we have no x-intercept. X-intercept is equal to none. After this, you can try to find the y-intercept. And this one's easy. You can try to input the x equals to 0. So y is equal to 2, and the y-intercept is 0, 2. And then you can try to find the turning point with the formula before. And the turning point, -1, 1, and the line of symmetry, x equals to -1. And again, x, y is going to be a minimum point. Right, let's try to draw the graph. We know that a is positive, so the graph will make a happy face. We have no x-intercept. We have a y-intercept over there. We have a turning point over here, and we have the line of symmetry. Now, in this case, as you can see, we only have 2 points. Can we actually draw the graph? The answer is no, we cannot. So in this case, the line of symmetry actually plays an important role, because as we know, the graph will be symmetrical to the line of symmetry, so any existing point that we know so far can be mirrored. So any points that we know so far can be mirrored just like this. So that is the point that results after the mirroring. And now, how can we find the extra points so that we can try to sketch the graph better? To achieve that, we can try to use a random x values. Yes, we can try random x values. For example, if x is equal to 1, we know that y is equal to 5. right? So the next point should be 1, comma 5, and then we can try to mirror it. So it's going to be 1, comma 5, and then minus 3, comma 5. So it's going to be over there. And now we can try to sketch the quadratic function like this. So again, the easiest way to get extra point is to mirror the points with the line of symmetry. That is what the line of symmetry is used for. It's used to help us if we are lacking in some points. Now let's try to take a look at this example. This one is going to be the opposite of what we know so far. Before, we tried to find the graph, and now we try to find the equation. Before we solve the equation, let's try to see informations that we have so far. So the graph is a happy face, and therefore we know the coefficient of x squared is going to be a positive number. And then we know the x-intercept is 2, 0, and 4, 0, y-intercept 0, 8, the turning point 3, minus 1, and the line of symmetry is x equals to 3. Now, if we want to find the function from a graph, it is best to use this form. It's going to be much easier because we know that we can get the h and the k directly from the turning point. So we know that the turning point formula is minus h, k, right? So we know that h is going to be -3 and k is going to be -1. So we can try to input those values and we got this. Now, how can we find the d? If we want to find the d, we can just use any available xy values, as we will see next. Let's try if we use 0, 8, the y-intercept. We can try to input the xy values, and as you can see, we will get that d is equal to 1. So now we have the complete expression. Y is equal to x minus 3 squared minus 1. If we try to expand this, we will get x squared minus 6x plus 8, and both answers are actually fine. Both answers are actually okay. In this next example, we're going to do a similar method, but as you can see, the graph is inverted. Let's try to gather up all the available informations. So the graph is going to look like a sad face. So that means the coefficient is going to be negative for x squared. And now we see that the x-intercept is minus 3, 0, and 4, 0. The y-intercept is 0, 12. The turning point is 0.5, 12.25. Again, we are going to use this form because we know that we can get the h and the k directly. So h is going to be minus 0, 5, and k should be 12.25. We can input those values, and to find the d, we can just input any available xy values. So let's try to input 0, 12, the y-intercept. If we try to input the x and the y values, we know that the d will be -1. After finding the d, we can try to write the complete expression like this. And if we want to expand it, it's also possible, which will look like this. And again, both answers are valid. Right, so these are the exercise that I've prepared for you guys. I hope you can do them. And as always, I will leave the answer for the exercise in the description box. So that's it for this video. In this video, we learned how to sketch a quadratic function. What do you think about this video? Please leave a comment and don't forget to leave a like and don't forget to subscribe. I'll see you on the next video. Thank you.